Well, good morning. My name is Mr. Morgan. I'm grateful, excuse me, you guys let me come and teach in your class today. Going to do a very simple lesson. It's kind of an enrichment lesson. It's not so much a lesson that you're going to have to learn, but it's kind of a lesson that lets you kind of know how people used to do things and lets you observe math as maybe it gives you an insight into how math was done in the past and some of the ideas that could be done. We're going to look at a thing called Egyptian multiplication. This will help you out when you go to Egypt next week. How many of you go to Egypt next week? 2, 3 people in Egypt next week. Great. Okay. The ancient Egyptians, I mean, you all know the Egyptians. What do you know about Egypt? They got the things. Have you taken geometry yet? Pyramids. Good. Pyramids, the Nile. They're coming out with a new movie this week. The Mummy. Yeah, they got mummies and all that kind of stuff. The Egyptian culture was one of the first major ancient cultures. They developed calendars. They had systems of weights and measures. They had a centralized government. It was a lot. I mean, it was a huge thing to have this government. And they developed this algorithm for multiplication. And you and I take for granted that we know how to multiply. You know, we did that in elementary school. You know, 5 times 10, and we learned our multiplication tables. But in the ancient world, the idea of multiplying wasn't there yet. And so multiplication was primarily being done by a system of adding things up. Instead of doing 3 times 5, you would go 5 plus 5 plus 5 plus 5 plus 5. And so that was tedious, and so they developed a simple algorithm to help them do multiplication that's actually still used in some parts of the world today. One of the problems they had, of course, was they had different numbers than we have. We use Arabic numbers that were developed by Muslims in about 700 AD. But prior to that, people had different ways of numbering. Here, for example, you can see the hieroglyphics in these different numbers. You can imagine if you had to write a million, go to the board and write a million 100 times. It's quite complicated. And these were their numbers. And one of the problems with numbers like this was using them. Anyone ever come across any other kinds of number systems? Any of you had to work with Roman numerals? Roman numerals. What was it like to add Roman numerals? It wasn't very easy. And neither was this. And you can see this creates a problem too as you're doing math. If you have these bizarre kind of numbering systems, it's hard to do it. And actually, it was a great jump forward when we developed the Arabic numbers that we use today. The way they would do multiplication was instead of multiplying as we do, they would add. And they did a process, and it was called doubling. The only thing you really needed to know how to do this process was how to double a number. If you could take any number and multiply it by 2 or add it to itself, then you could do this type of multiplication. It's called doubling. And I want to show you real quickly how it works. And then we're going to try some out in the class. For example, if we take the number 22 times 21, we can pick either one of these numbers. In this case, we'll take the number 22. We'll just start making a little chart here. 1 times 22 is 22. Now, the next line is simply double it. 2 times 22 is 44. The third number will double again, double 2 to 4, double this, 88, 8, 176, 16, 352, 32, 74. So you see, all we've done in each case is simply taken the number and doubled it, then doubled that, then doubled that, then doubled that, then doubled that. Until we've doubled it enough times that it's greater than the number we're multiplying by. We want to multiply by 21. Now we simply look over at these numbers, 1, 2, 4, 8, 16, 22, which are simply our numbers of 2. 2, 4, 8, 16. And we say, which ones of these add up to 21? And so we say, well, we'll take the largest, 16. 16 and 4 is 20, and one more makes 21. So we found 16, 4, and 21. So then if we'll take these three numbers, 352, 88, and 22 and add these three together, we'll get our number 462. And that's how they did multiplication. Seem complicated? It seems fairly simple. 22 plus 88, 110, and then plus the 352, 462. And that was the way they did their multiplication. Let's take another example. Let me do this one when I choose. 5 times 12. Just to show it on the board for you again, let's take 5 times 12. If I simply make up a little T-chart, and I'm going to do 5 times 12, well, 1 times 12, and so 2 times 12, what's 2 times 12? 24. Now we double this, so we're at 4. So what's 2 times 24? And which of these factors will add up to 5? Which one? 4 and 1. So if I add up the 4 and the 1, I get my 5. So all I want to take over here is these two factors. And when I add them up, I get 60. And so now you see, and that's the answer you would have got already in your head. You already knew that before we did the problem. But this was the way they did it. Again, the reason they did this was they did not have the concept you and I have of multiplying like we do. So they had to do it by adding things together. And instead of saying 12 plus 12 plus 12 plus 12 plus 12, they found this to be an easier way to do it. Does that seem simple to you? Okay. What I'm going to do, you're already in groups. Looks like the groups are fine. I want them to be 4 or less. So this group back here will actually break it into 2 groups of 3. I'm going to give you a worksheet with three problems on it. I want you to take one person in your group to be the recorder and kind of record the groups, and then I want each of the other problems, one person in the group to lead the discussion. But you want to work the problems together. Now you have no problem checking them out because all of you know how to multiply them regularly. So let's take a moment and go through and do these 3 problems, and then we'll come back and see if there's any questions. And then there's one last question on it that I want you really to look at, because the purpose of the lesson really wasn't to teach you how to do Egyptian multiplication. I doubt very many of you are going to go out of here and go to the store and sit there and go, all right, how does this Egyptian multiplication work? You've got to figure out how much, if I buy 3 pairs of shoes, how that's going to work. The purpose I want you to see is the last question and to ask, why does that work? And you should know by now in algebra have some properties and things that you understand to understand why does this system work? Is it just a cute little trick, or does it actually work? So let me pass out your worksheets, and we can get started.
Your daughter.
You started 5 here.
You did 5 and then 1 times 12.
I get it.
Put this, you can do, start with your 25, put your 25 here. Think of it this way. Think of doing 1, 2, 4, 8, and then put 25 here and double that. So it's 2 times 20, 50. And then double 50. And then double 100. See, we've done just like we doubled that. Now you're at a place where you can pick out these at 12. If you look here for just a second. One easy way to start this problem is know that you're always going to have on the left side these numbers. 1, 2, 4, 8, 16, 32 if you were to go that far. But every one of your charts is going to start this way, because these are your factors at this point. And then your other number, whatever you're multiplying by, will start here, and then x, 2x, 4x, 8x, all the way down. I mean, multiplying those numbers. But every one of your charts will have it in this column to begin with. So you can put in each of those columns, the left column to be that way. That will be a good starting point. Remember, you can work together. You've got a question? You okay? How are we doing here? Yeah, they can. You're just picking any two of those factors that will add up, 2 or 3 of those factors that would add up to 12. Then one would be fine. In this case, you multiply. In this case, it was a simple one because it ended up being one of the factors. So, I mean, you could even have taken.
Double check that one too.
Got them all? How about the last question? When you finish them, think about the last question. Why does this work? Or is it just a trick to amaze your friends? Yeah, why it works?
I know how to fire pen.
Okay, let's take a shot at these. Which group we're going to do problem one? It's nice to be honest. Okay, 8 times 17. Let's see, he did it right in his paper, so it's hard to be wrong in the board. Don't get you nervous. Each one you're double is 17, and 17 is 20, 34. 34 and 34 is 68, 68 and 68 is 136. Everything is simply double. Okay? Now, at this point, we've just got these little, and we don't need these. Because once we get down high enough, higher than this, we don't need to go any higher. So now, which of those factors add up to 8? Okay. This one was incredibly easy because all you needed was, once you got down to 136, to the 8 was the one you were multiplying by. So that you only needed one factor. Now notice if I had wanted to, I could have taken 4 and done 2 of 4. I could have said, well, 4 is 68, and I'm going to have a 4 and a 4, and I could have gotten my answer that way too. But that defeats the purpose. You're trying to use the largest number of factors you can. Okay. All right, let's take a volunteer from this table back here to do problem number 2. There you go. All right. You notice here he's marked these two. Here's the thing. 25 doubled is 50, 50 doubles 100, 100 doubles 200, fine there. And the needed factors adding up to 12, because he's going to multiply 25 times 12. He picked 8 and 4. So 8 and 4 is 12, 100, 200, 300. Good job. All right. Okay. Someone from this table over here, do our last problem. Which one of you guys want to pick up the last one? In this case, again, we doubled the 13. He chose the 13. By the way, you could have reversed this and put the 9s here and did your 13 over here. In this case, he chose the 13, the 1, and the 8, the 104, to give him his 117. Now, the question I want to ask you is, why does that work? Why does all of this work? What's going on behind here that allowed this type of thing to give you that answer? What do we have in this particular problem here? We have 9 times 13 is what we're looking for, correct? In this case, we broke out some factors, and here we have 1 times 13. Let me back up a second here. We have over here the two numbers we added together were what? We added 13 plus 104 to give us 117. Where did we get the 13 from? What was it? What were the factors that gave us 13? 1 times 13. And where did we get the 104? 8. So we had 8 times 13 equals 117. Now when you look at it that way, why is this thing working? Could you simplify this? We can take the 1 and the 8, and what will that give us? 9 times 13. Which was what we were looking for. Now, what do you call this property here? I know you have to go all the way back to Algebra 1 to remember that property. Y is, put it in your algebraic terms, you remember this. What does A plus B times C equal? AC plus BC, which was the distributed property. Okay? And see, all they've done here in multiplication is they've made all these factors, and then they picked the factors that add up to 9, and simply it's just doing what you always do all the time in your distributed property. And so that's the reason that the Egyptian multiplication works. Does that make sense again? They've broken out the different factors. For example, you could have on this problem, if you wanted to, instead of just doing 8 plus 1, you could have done 4 plus 2 plus 2 plus 1 times 13. And taken each of those and taken 52, 26, and 26, and 13, and you'd come up with the same answer. Because you were simply taking the number of factors, spreading them out, breaking them out. But in the bottom line, all we're dealing with here is an understanding of the distributive factor, and that's what makes it work. Okay, any questions? All right, I want to thank you for letting me be in your class today. And the good news is I don't have any homework for you today. All right. So you guys have a good day, and thank you again.